Section number 3 is going to start talking about acceleration. What we're going to do is we are going to expand on what we've been talking about with speed and velocity. Let's go ahead and let's talk about a baseball game. I want you thinking about a pitcher getting ready to pitch a ball, and all of a sudden the batter is going to end up hitting a home run. The thing is, as you go ahead and look at that pitcher, the pitcher is going to be getting the sign from the catcher. They're going to go through their windup. All of a sudden, they are going to throw the ball towards home plate. That ball all of a sudden accelerates in their hand, getting faster and faster and faster, and we'll say they throw a 96-mile-an-hour fastball. As that ball is coming towards home plate, the batter spots it. They swing the bat, and as that ball is coming towards home plate and coming in contact with that baseball bat, the ball's slowing down to a point at which that ball actually comes to a stop. Well, as that bat continues on around, it's going to redirect it towards the outfield, and all of a sudden the ball speeds back up and goes over the outfield fence for a home run. The thing is, that ball went through many changes in motion. We said that it was speeding towards home plate. We said that it came to a stop. We said it was redirected, changes direction, now all of a sudden heads back towards that pitcher, over his head and towards that outfield fence for a home run. If you think about a car sitting at a stop sign, not moving, look left, look right, all of a sudden step on the accelerator, and all of a sudden that car is moving faster. All of a sudden the driver looks down and it says 15 miles per hour. Did they go from 0 to 15 instantly? No, we know they didn't. We know that that car was speeding up over time. Acceleration is just going to be a rate of change of velocity. It's how fast that object is going to be changing its velocity over a certain amount of time. What we're saying is acceleration is that change of velocity divided by time. And if we go ahead and break it down even further, we're going ahead and we're saying, take the final velocity, whatever we ended at, subtract away that initial velocity, whatever we started at, and divide it by the time interval. And that's going to be important. Always take the final minus the initial. Units for acceleration. Well, again, the other day when we were talking about velocity and speed, we said one of the units was going to be meters per second. If we go ahead and divide it by the time interval, or that SI base unit for time, seconds, acceleration is really going to end up as a meter per second, or we can say it's going to end up at meters per second squared. Because acceleration deals with velocity, acceleration also has to have a direction, and that is going to be the key thing. When I'm looking at your assignments, I'm going to be looking for a direction. If one isn't given to you, you can go ahead and just say forward. Okay? Or if it says that the object is moving backwards, then of course the direction is going to be backwards. Up, down, left, right, north, south, east, west, whatever direction is going to be given to you. At the top of its highest hill, it says a roller coaster's velocity is 10 meters per second. Now, if we're talking about it is, that is going to be the initial velocity that we're talking about. It says downward it gains speed to all of a sudden we're moving at 32 meters per second. That's what we end at. That's the final velocity right there. And it says it does this all in 3 seconds. And the question says, what is this roller coaster's acceleration? So when I look at my equation, VF minus VI divided by time. Plugging those numbers in, we said that the roller coaster car was going to end at 32 meters per second. We said that it started at 10 meters per second. So what you're going to do is you're going to have to do this in parentheses first. Take 32 minus 10, end up with 22 meters per second, and then take that 22 meters per second divided by 3, and what we'll end up with is 7.3 meters per second squared. The only thing I'm missing here, notice, I didn't give you a direction. So if this was your answer, I would count it wrong, okay, or count part of it wrong. It would be worth 2 points. The thing you would also have to add on here is that direction downward. So the correct answer should be 7.3 meters per second squared down. So I would want to add in down portion for it, or downward. The size of an acceleration is going to depend on 2 things. Number 1 is going to be the change in velocity. Obviously, larger change in velocities are going to give you larger accelerations, and also the time interval. And as I said, if the change in velocity is large, the acceleration is also going to be large. Also, the acceleration can be large if the time interval is extremely small. Remember where time is. Time is in the denominator. Okay, it is in the bottom of a division problem, and the smaller the number gets when it is in the denominator, then the larger that answer is going to end up being. Okay, so two different ways to cause acceleration to be large. If you think of a drag race car, okay, any of you that might like watching drag racing, again, you have that drag race car sitting at the starting position. As that car is sitting in the starting position, it's not going anywhere. All of a sudden, you see the little Christmas tree go to green. All of a sudden, the car spins its tires, and all of a sudden, it's going down the track, going faster and faster and faster. Once they cross that finish line, parachute pops out. And instead of continuing on at like 300 miles per hour, all of a sudden as that parachute comes out and they apply the brakes, that car slows down very quickly where it eventually comes to a stop. So my question is, think about it. Is the drag race car or is the drag car accelerating over the entire time? Some of you might say, no, it is not, because we're so used to hearing that word accelerating as meaning going faster and faster and faster. Look back at the word acceleration. Look back at the definition for acceleration. And when you look at that definition, you're going to notice that it says a rate of change of velocity. When I speed up, am I changing my velocity? Yes, I am. When I slow down, am I changing my velocity? Yes, I am. So technically, that drag race car is accelerating over that entire time frame. If we look at a drag race car, it says it's traveling at 135 meters per second, slows to a stop in 6.5 seconds. What is the dragster's acceleration? Again, I'm going to take VF minus VI. Now you might look up there, VF, VIT, that's three variables. Why do I only have two numbers here? I do actually have three. It says that the car slows to a stop. Stop, that's going to be my VF. That's going to be 0. So when I look at the numbers, 0 minus 135 still gives me negative 135. Dividing it by 6.5, I end up with an answer of negative 20.77 meters per second squared. It's important that I get that negative, and the reason why it's important to get that negative is because the car is slowing down. Because acceleration can be speeding up or slowing down, two words were created to not confuse the two. Acceleration, which we're often familiar with as meaning increasing speed or increasing velocity, and the other one is deceleration. Deceleration just means decreasing your speed. But because this is science, I am only going to use the word acceleration. I'm going to use acceleration to mean increasing or decreasing. There's three ways to change the acceleration. We've already talked about the first two. We can go ahead and speed up. We can go ahead and slow down. The other way to change acceleration is think about it. Think about what the definition of acceleration was. The rate of change of velocity. And again, what was unique about velocity? Velocity was just going to be how fast you're going in a given direction. So the other way to change acceleration is going to be to change your direction. So three ways to change acceleration: speed up, slow down, change direction. Your assignment for tomorrow is to read pages 302 to 305. There are 4 questions on page 306, and then a worksheet that'll be passed out to you.